Hi, everybody. So today I want to talk about the method of partial fractions. So this method is basically a way to kind of go backwards from a fraction addition. And in particular, when you do this, you want to do this with a rational function. So you're looking at functions with numerators and denominators, and both of those are polynomials. And so then those are the things we're trying to sort of uncombine. So the idea would be something like this. So if I take something like 1/2 plus 1/3, the way that I add these two fractions is I find a common denominator, and a common denominator is going to have to be some multiple of each of those 2 and 3. And so in particular here, this is the least common denominator here is just going to be 6. So I multiply the first one by 3/3 and the second one by 2/2. And then I end up getting 3 plus 2, both over 6. And that's ending up just giving me 5/6. So the question is now, can I go backwards from that? So if I, for example, give you something like 11/7, 11/14, what I would like to know is for 11/14, what is something over 7 plus something else over 2. So there's 7 and 2 are the two factors of 14. That would give me 11/14 when I added them. That's kind of the question. So the idea here is kind of to split up that fraction as much as I can. And the trick for doing this is actually the same as it would be for a rational expression. I'm just going to multiply by the denominator on both sides. And so what you'll see here is that the denominator cancels on the left. So I get 11, and then I get 2a plus 7b on the right. And so now at this point, I have to eyeball it because there are all sorts of choices for A and B. But if I chose B to be 1 and A to be 2, I get 7 plus 2 times 2 is 7 plus 4 is 11. And so I then would say, oh, okay, so that means that 2/7 plus 1/2 is equal to 11/14. So I sort of look at these A and B and try to find them. Luckily for us with the rational expressions, we've got a lot more information to go off of. And so this sort of solving is not just a guess and check kind of perspective at the end, like prospect at the end, right? And so what I want to do here is just talk very briefly about this in terms of this rational expression here. So 3x over x squared plus 2x minus 8. And so what I kind of do here is I say that this is 1/x minus 2 plus 2/x plus 4. And then I kind of find the common denominator, multiply them, get them all together, and then I get 3x over x squared plus 2x minus 8. So now the question is how can I go backwards? So if I give you this, how can you go backwards to this? And maybe the real question you're going to ask is, why do I care? So I can turn this 3x over x squared plus 2x minus 8 into a 1/x minus 2 and a 2/x plus 4. Well, so the reasoning is, think about the integral. So I'm looking for the antiderivative of 3x over x squared plus 2x minus 8. And now I have to be very careful there because how am I going to do that? I need a u substitution maybe. But if I let u be the whole denominator, then du minus 8. Then du here is going to be 2x plus 2. And I do not have some multiple of x plus 1 on top or like a 2x plus 2 on top. So in particular, I just have a 3x on top. And so it sort of is bad. Now, if I take the integral of the other of these two things, because these two are equal, I can turn this into that other fraction. Well, I can integrate 1/x minus 2 plus 2/x plus 4, and that is extremely straightforward. So both of those, I do a u substitution, so I just ignore this part. I do a u substitution, u is x minus 2, du is dx. So I don't have to do anything except just say that's going to be ln of u, which is ln of x minus 2, absolute value of x minus 2, right? And then that is plus, there's a 2, so that 2 comes along for the right, and I get, again, just get an ln of x, absolute value of x plus 4. Plus constant c. And so this is really nice. So if I can turn this fraction into a split up version of that fraction over the denominator being the factors of the thing on the left, then I'm going to be a lot happier when I go to integrate it. So let's just see what we can do with this example. So I'm looking at my 3x over x squared plus 2x minus 8. And I know what I should get in the end. So what I should get in the end is, I just should get 1 over x minus 2 and 2 over x plus 4. So how am I going to get that from what we have here? So what we're going to do is exactly what we did before. I'm going to say, oh, let's factor this thing in the bottom. And then let's look at the two factors. Two factors are x minus 2 and x plus 4. So x minus 2 is going to have something over it. X plus 4 is going to have something else over it. I need to now figure out what are a and b. So I said the trick is going to be the same as it was in before, which is just to multiply by the denominator on both sides. So I multiply by the denominator on both sides, and you'll notice the x plus 4 survives when I multiply by the a, and the x minus 2 survives when I multiply by the b. So I sort of distribute all of this through. I get ax plus 4a, bx minus 2b. Let's group everything with an x together and everything else together. And then I've got a plus b, x, and 4a minus 2b. So I've sort of grouped my two terms that have a in them together, and then I factor the x out, or x in them together, and I factor the x out. And then I have a plus 4a, a minus 2b, and here as the next grouping. Okay. Now I know something about the coefficients, but in particular, I also know that the left-hand side of this thing is just the numerator of the fraction that I was talking about. And so I know that the x term on this right-hand side should be the same as the x term over here. So 3 should be a plus b. And I also know that 0, there's no constant term, should be equal to 4a minus 2b. And now this is a problem from college algebra. So you're basically looking at a system of equations. This is 2 variables, 2 equations, and you just have to solve this however you can. So there's a lot of ways to do this. You can do sort of solving by substitution, and that's what I would do here. I would just solve for maybe b, I'd let b equal 3 minus a, and then I would plug that b into my other equation. And then I might get, that just leaves a's, and then that a is now solved, and then I want to have a, I plug it back into 3 minus a and gives me b. So I can find a and b out of that, and it will end up giving the right things. Or I can do the other method, which is just to do an elimination. And so I look at my two equations and I say, can I multiply the first one by something to eliminate one of the two variables when I add the two equations together? So in particular here, I might multiply the first one by 2. So I get 6 equals 2a plus 2b, and then add it to the other one, and the 2 and the 2 minus 2b will cancel. So 2b and minus 2b will cancel. And so I'm just left with a's again, and then I've got an a, and then I can plug that back in to give myself the b. Okay. So I do that. I get 3 equals a plus b. 0 is 4a minus 2b. That gives me 3 minus b. Plugging it in gives me 12 minus 4b minus 2b. And that's going to give me 12 is 6b, or b is 2. And then a is 3 minus b, so a is 1. So a is 1, b is 2. That's great. That's exactly what we wanted. We wanted 1 over x minus 2, 2 over x plus 4. And notice it didn't matter like the order in which I wrote my two things. I would have just switched a and b. So a and b would have just been different numbers. But they would have been the same two numbers, and they would have corresponded with the denominator in each, which is great. So here we're very sort of happy with this. Then I can integrate this thing and sort of be done. So let's talk about the general technique for this. So that if I only have what I call simple linear factors, that is to say, all I have is x minus something, x plus something on the bottom. That's how I factored it. And all those factors are raised to the first power. So there's no powers of these factors. So it's not like x minus 2 squared is one of the factors. And so I've got just single powers of each of those. And if they're all different, then I can actually do a decomposition, partial fraction decomposition, by just writing it as a over the first one, b over the second one, c, et cetera, right? And here I just do a1, a2, a3, and so on, because I don't have sort of enough letters in the alphabet to sort of do this for any number of things. So I just make the subscript correspond to which of the roots I have in my denominator. Multiply both sides by the denominator, that will clear out all of the denominators. So everything here will be just have numerators, and it's all just going to be equal. And then I solve those a1, a2, and so on using systems of linear equations, because that's what I'm going to end up getting is just systems of linear equations equating to things in p of x, the numerator of my fraction. then I solve for those AIs, and then I can kind of go from there. So let's do an example. So here's an example. I have x cubed minus x squared minus 2x. That's my denominator. So I'm going to factor it. It's going to be x, can come out of all of them, x minus 2x plus 1. And now I'm looking for an a and a b and a c. So that a over x plus b over x minus 2 plus c over x plus 1 is 3x squared plus 7x minus 2 over x minus 2, x plus 1. Okay. So my question now is, how am I going to do this? What do I end up getting? And so we kind of work through this. We multiply both sides of my equation by x minus 2, x plus 1. The left-hand side will just become 3x squared plus 7x minus 2. The right-hand side, well, I've got a, the x has canceled, and I'm just left with x minus 2, x plus 1, which is x squared minus x minus 2. Okay, so this here is the product of those two. B, I'm left with x and x plus 1, which is x squared plus x. And C, I'm left with x and x minus 2 is x squared minus 2x. And so what I'm left with here is a plus b plus c times x squared minus a plus b minus 2c x minus 2a. Okay. And that is all equal to this 3x squared plus 7x minus 2. So what this actually will give me now is a system of equations. So a plus b plus c is 3, because that's the thing that's in front of x squared, minus a plus b minus 2c is 7. That's the second term, the term with x, and minus 2a is minus 2. Okay, so here there's sort of an easy one. I can divide the last one by minus 2. That gives me a equals 1. Okay, now I have a little bit of trouble. So I have a b and a c in both of the other two equations. So it's sort of harder to do a substitution, but it's not terribly bad. So I'm going to actually do this. I'm going to put the a equals 1 into the first equation and the second equation. So that's going to give me really 1 plus b plus c is 3. Or b plus c is 2. So I can subtract the 1 across. The other one gives me minus 1 plus b minus 2c equals 7. Or b minus 2c equals 8. That gives me my two equations now. And so I ignore the ones that have the minus 1 and the 1 in them. And now what I'm left with is these two. So I can solve for b or c in this first equation. Let's say c equals 2 minus b. I plug that into my second equation. So I get b minus 2 times 2 minus b is equal to 8. And so I multiply this through. I get b minus 4 plus 2b is equal to 8. Add 4 across. 3b is 12, or b is 4. So b is 4. And if b is 4, from this equation here, or this equation here, c is negative 2. Okay. So what does that mean? Well, in particular, b is 4, c is negative 2. What that means for me is that this fraction is 1 over x, 4 over x minus 2, and minus 2 over x plus 1. So it's 1 over x, 4 over x minus 2, and minus 2 over x plus 1. And now I integrate each of those. The integral antiderivative of 1 over x is natural log x, absolute value of x. It's going to be 4 natural log of x minus absolute value of x minus 2, and minus 2 absolute value, natural log absolute value x plus 1. So that's what I get. And then I got a plus k here. So I'm doing this because I used c previously. Just be really careful. My math lab will accept only a c. So they want the c there, even though I've used c in my calculation above. So it's just a little bit tricky there to sort of do that. So I use a k there, but in my math lab, they're going to want that to be a c. All right. Now I'm kind of done. I just have to be a little bit careful, because what they'll do on my math lab is they will simplify these things. So what they're going to do is they're going to bring the product inside here as an exponent, and then they're going to combine all the natural log terms into a single natural log. So they're using the log rules from your college algebra class, meaning if I have the natural log of two things multiplied, that's the sum of the two natural logs. And if I have the natural log of a quotient, this is the difference of the two natural logs. And then finally, if I have a constant times a natural log, it's the natural log of that number inside raised to the constant term out as an exponent. Okay, so I can bring in the exponents as well. And so that's sort of this idea that I want to do all those steps. I can bring in the 4. That's a fourth power. The fourth power of something is always positive, so I can drop the absolute value there. Same with the -2 power. The square of something is always positive, and so I can bring that in. And that minus makes it go to the denominator. So I have a minus on the bottom, or an x plus 1 squared on the bottom. And then I have an absolute value of x and x minus 2 to the fourth on the top. Okay, and so MyMathLab will sort of take this answer, and that's what it'll show you. It will, I believe, accept this answer as well. If it doesn't, make sure you just go through and do that sort of simplification before you kind of just force give up or just screamingly give up or whatever. It's gonna want that. So my guess is that MyMathLab accepts that, and I believe it does. It almost always has. So there you go. So that's great. So this works really well as long as those terms in the bottom are different. So I have an x minus 2, x plus 1. If any of those are raised to a power, I have a little bit more trouble. So what I have to do is I have to actually add extra terms to this. So instead of just having something over x minus a to the power, I have something over x minus a, something over x minus a squared, plus something over x minus a to the third, and so on, up until I hit that power, which is in the denominator. So if I have x minus a to the m power in the denominator, then the right-hand side of the equation has these terms in it, in addition to any other terms that I might have. Okay, and we'll do an example of this that I think makes it a little bit clearer to see, but that's the idea. The technique is almost exactly the same. I just have more terms to actually deal with here. So I've got more to work with. So let me give you an example. So we've got 5x squared minus 3x plus 2 over x cubed minus 2x squared. So the denominator here is x squared and x minus 2. X squared, that is going to be like what we were just talking about with the powers. So this is a power of x. So what I'm going to need to do for my partial fraction decomposition is I need something over x plus something else over x squared plus something else over x minus 2. And so I've got sort of 3 terms in here that I've got to deal with as I'm going forward. Now this is sort of not bad news, really, because this second term, it cancels out more of the numerator when I multiply, and so that denominator gets more canceled, and so I kind of have some extra leeway here, a little bit of wiggle room throughout this. So I'll multiply both sides and sort of clear out the denominator. What do I get? The right-hand side, A is x minus 2, B is x minus 2, C is x squared. And so I sort of have those 3 terms. The left-hand side is just 5x squared minus 3x plus 2. I'm going to FOIL or distribute it all through. I get ax squared minus 2a x, and I get bx minus 2b, and I get cx squared. So that's what I get. And so now I set up my equations. So a plus c is 5. B minus 2a is negative 3. So that's the second equation. And minus 2b is positive 2. So b here I can solve. I divide by minus 2. I get negative 1. So b is negative 1. I can solve for a then, because b minus 2a is b minus plus 2. B plus 2 is negative 3. I'm going to subtract 2 across. Wait, what did I do wrong here? Oh, sorry. Negative 1 minus 2a is negative 3. So I sort of add that 1 across. It gives me negative 2. Divide by negative 2, I get a is 1. And then c is 4, because a plus c is 5. And 1 plus 5, 4 is 5. So that's how I get that. And so then I go. And then now I've got 1 over x minus 1 over x squared plus 4 over x minus 2. And so then I integrate each of those terms, and then I combine them all into a single logarithm. And then notice I do have one extra term here, this 1 over x. That comes from integrating negative 1 over x squared. Because if I'm thinking about this, I'm integrating negative x to the negative 2. And this one I do not need to use as a natural log because it's actually can be done with a power rule. And so what I get is x to the negative 1, negative x to the negative 1 divided by negative 1 is just positive 1 over x. So I have a plus 1 over x coming in here. That's coming in from this 1 over x squared. And this will happen when I have powers of these things in the denominator. So powers of these things in the denominator, they're just going to be the power rule as I go there, unless it's the first power and then I do natural log going from there. Okay. Finally, there's one actually more hiccup throughout here, and that is if I don't just have linear terms. So there are quadratics that have only complex zeros, in particular, something like x squared plus 1. There's no way to factor that into linear terms with real coefficients. I have to have it's x plus I and x minus I, but I is something that we haven't dealt with and we aren't going to deal with. So what we're going to do is we're going to leave it as x squared plus 1. So what we call this is called irreducible. So I cannot factor it any further. And one of the things about our sort of real numbers here is the only irreducible polynomials are quadratics. So anything that has a higher power than a quadratic is not irreducible. I can actually factor it into smaller things, possibly a bunch of quadratics, or maybe a quadratic and some linears, or maybe just a bunch of linears, right? So anything with bigger powers than 2 ends up factoring further. So you can always factor it further. Okay. And in that situation, the right-hand side gets an additional sort of hiccup in here. I get an ax plus b on the top of that quadratic factor. And so that is a little bit tricky. But again, it's not so bad. It basically just kind of adds a little bit of a hiccup to it all. And if I have powers of that irreducible quadratic, I just have a term for every power. And again, that term has both an a and a b with an ax plus b in each term there. So let's try this, for example. So x squared plus 4 is an irreducible quadratic. I cannot factor it any further. It has roots that are 2i and minus 2i, and I cannot factor i's and really can't really factor into i's, so that's no good. So what I'm going to do is do the partial fraction decomposition. I put something over x and I put something over x squared plus 4. And that something over x squared plus 4 has a bx plus c in it. And so that's the hiccup, right? So I just need to add an x term on the top of that quadratic. Okay, and you can kind of think about this in terms of division, polynomial division. So when you do a division by polynomials, you will get a degree lower than you had before when you do this division by a linear term. And so what ends up happening here is like I have a degree lower on top than I have on the bottom. So the bottom here has a quadratic in it. So the top has a degree lower. It has a linear term in it with an x to the first power. Okay, so I multiply both sides by this thing, and that's the wrong thing. This should actually be multiplied by x times x squared plus 4. And so what I get here is I get 4x squared plus 4, which is the numerator, is x squared plus 4 times a plus x times bx plus c. So I kind of combine everything that I can here. I end up with a 4x squared is a plus b. The x term here is there's nothing there, so it's 0. So c is already 0. So I already have one of my two terms. And here 4a is 4. That means that I can actually solve this really straightforwardly. So c is 0. I'm done with that. A is going to be 1 because I divide, and then b is going to be 3, and then c is 0. So now we can integrate this thing. Let me clear this out of here. So now I can integrate. And so what I get here is just natural log of x. And the second term here is a little bit weird. So I have to do a u substitution. Here u is x squared plus 4. Du is going to be 2x dx. So I can end up with this. And so what I end up getting here is there's actually like a 3/2 natural log absolute value x squared plus 4. Because that's just a natural log of u in there, and then u is x squared plus 4. And so that's great. Okay, and I can do the combining thing like I did before as well. So I can also do this as the natural log of the absolute value of x times the absolute value of x squared plus 4, which actually is always positive, so I can sort of do that, raised to the 3/2 power, plus my constant k, and that again could be c. So c is the one that they want in my math lab to go through this. Okay, so the kind of takeaway message from all of this is know how to sort of get the partial fraction decomposition, because once you have that, the integration is something that you should be able to do with just a u substitution or something like that. reverse the power rule or have the natural log come in. And so getting to that point of having the partial fraction decomposition is sort of how we do it. And so you get something over the first factor, something over the second factor, something over the third factor. If there's a power of a factor inside of there, it turns into something over the first power, something over the second power, and however many powers that thing has, there's that many terms introduced. And the last tick up, if I have a quadratic that is irreducible, I end up with like an x term on the top of that, as well as a constant term on the top. So a bx plus c rather than just a c on the top of x squared plus 4. So that x squared plus 4 has to have an extra x term, a linear term in it. Again, it's 1 power lower than the denominator. And each of the other ones, they're all linear. So the power lower than that is just the constant. There's no other power. And then for a quadratic, you need an x term in the top. Okay. And it works out pretty nicely sometimes, and almost, and in fact, all of the ones we give you on My Math Hub should end up pretty nice. You'll get the A, B, and the C. It won't be too hard to get those. And so that's the big trick out of all of this, is to get that A, B, and C, or A and B, or whatever they are, and figure out how to then integrate the thing from there. All right. So with that, I think I'm going to leave you to it and go ahead and get that done, and we'll see you next time.